Hello everyone. Today we will learn about the regression. Regression is an estimation of one independent variable in terms of the other. The best fitting line of form y is equal to ax plus b is called regression line of y on x, and x is equal to ay plus b is called regression line of x on y. To find the correlation coefficient, we have formula r is equal to sigma square x plus sigma square y minus sigma square x minus y divided by 2 sigma x sigma y. To find the regression lines of y on x, we have formula y minus y bar is equal to r sigma y by sigma x into x minus x bar. X minus x bar is equal to r sigma x by sigma y into y minus y bar. This is the regression line of x on y. So we'll first look for a problem which is compute the coefficient of correlation and equations of the lines of regression for the data. These are the x values, which is an independent variable, and these are the y values, which is an dependent variable. We will find the coefficient of correlation using the formulas r is equal to sigma square x plus sigma square y minus sigma square x minus y divided by 2 sigma x sigma y. So we have x values, y values. We'll find out z values, which is x minus y, x square values, y square values, and z square values. And we will find out substitute summation of x, summation of y, summation of z, summation of x square, summation of y square, and summation of z square. We'll find out the mean of x, mean of y, mean of z. So we'll find out sigma square x, which is summation of x square by n minus mean of square of mean of x, and so sigma square y is equal to summation of y square divided by n minus square of mean of y. Sigma square z is equal to summation of z square by n minus square of mean of z. By substituting these values in the formula, in r is equal to sigma square x plus sigma square y minus sigma square x minus y divided by 2 sigma x plus sigma y, we will get the r value, which is 0.93. Will From using r, we will found out the lines of regression are given by y minus y bar is equal to r sigma y by sigma x into x minus x bar. So by substituting the r, we will get y is equal to 0.93x plus 7.28. And by substituting the r in x minus x bar is equal to r sigma x by sigma y into y minus y bar, we will get x is equal to 0.93y minus 6.23. So we will look for a Python code to find out the coefficient of correlation, and the this is a Python code to find out the coefficient of correlation and lines of regression. So these are the x values which we have seen in the above problem, and these are the y values. We have to import numpy to for the mathematic computation, and we have to find the calculating means of the x and y, which is mean of x and mean of y. We will find out to find out the correlation of coefficient. We need numerator and denominator, which is numerator is equal to summation of x minus x mean into y minus y mean, and denominator is equal to square root of summation of x minus x mean whole square into summation of y minus y mean whole square. So we will find the correlation coefficient, which is numerator by denominator. We'll find the standard deviation sigma x is equal to np square root of summation of x minus x mean whole square divided by n, and sigma y is equal to square root of summation of y minus y mean whole square divided by n. Calculating the coefficients of regression line by using r into sigma y by sigma x and r into sigma x by sigma y. So we will print the correlation of coefficient and lines of regression. So we will get the correlation coefficient is equal to 0.93, and y is equal to 0.93 into x plus 7.29, and x is equal to 0.93 into y plus minus 6.21. So we will look for another problem to find out the correlation coefficient and equations of lines of regression, which has x values and y values. We will find out x values, y values, z is equal to x minus y, x square values, y square values, and z square values. We have summation of x, summation of y, summation of z, summation of x square, summation of y square, and summation of z square. We'll find the mean of x, mean of y, mean of z. And to find out the sigma square x is equal to summation of x square by n minus square of mean of x. We'll find out the sigma square y is equal to summation of y square divided by n minus square of mean of y. We'll find out the sigma square z is equal to summation of z square by n minus mean of z square. We'll substitute these values in r is equal to sigma square x plus sigma square y minus sigma square x minus y divided by 2 sigma x by 2 sigma y. We'll get r is equal to 0.81. By substituting the r in these formulas, y is equal to y bar is equal to r sigma y by sigma x into x minus x bar. We will get y is equal to 1.306x plus 1.082, and substituting the r in x minus x bar is equal to r sigma x by sigma y into y minus y bar, we'll get x is equal to 0.502y plus 0.49. These are the lines of the regression. So we will see the Python code to find out the same correlation coefficient and lines of regression. So this is a Python code. We have x values, which is an independent variable, and y values, which is an dependent variable. We will have to find out the means, mean of x and mean of y. We to find out the correlation coefficient, we have to find the numerator, which is a summation of x minus x mean into y minus y mean. And to find out the denominator, we have is denominator equal to np square root of summation of x minus x mean whole square into summation of y minus y mean whole square. By substituting the numerator and denominator, we will find out the correlation coefficient. To find out the to standard deviation, we will find out sigma x is equal to square root of summation of x minus x mean whole square divided by n and and to find out the sigma y, will have to square root of summation of y minus y mean square divided by n. Calculating the coefficient of regression line, we have to multiply coefficient of regression into sigma y by sigma x, and coefficient of y will find out r into sigma x by sigma y. So we will print the coefficient of correlation and lines of regression. So we will get 0.81, and lines of regression of y on x is equal to y is equal to 1.30x plus 1.10, and lines of regression of x on y, x is equal to 0.50 into y plus 0.50. So thank you.